Everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, number of beautiful subsets. The problem states that you are given an array nums of positive integers and another positive integer k. You need to return the number of non-empty beautiful subsets of the given array nums. Now, a subset is called beautiful if it does not contain two integers with an absolute difference equals to k, right? So let's take an example. Let's say the array is 246 and k is 2. It means a subset is beautiful if it does not contain two integers which have an absolute difference of 2, right? So let's say we consider subset 246. Now this subset is not beautiful because it has two integers, let's say 4 and 6, which have absolute difference of 2, like 6 minus 4 is 2, and this is equals to k. So basically, because it contains two integers which have an absolute difference of k, this subset is not good or not beautiful. You can try this exercise for all possible subsets of this given array, and you will see there are only four such subset which does not contain two integers which have an absolute difference of k, and hence the answer here is 4, right? Now before jumping to the solution, I would like to say that this video can be a bit lengthy because I would try to explain the concept where we have to find the subset using bit set from scratch, because I get this feedback from you in the previous video that you have find difficulty in understanding the bit set concept. So I would try to demystify it in this video. If you already know about the bit set concept, and you can simply jump back and forth into the specific section, as always that all the timestamps will be there in the description down below. So with that, let's get started. So before jumping and solving this particular solution, we will discuss how to find subset of a given array efficiently, right? So again, there are various different ways to find the subset of a given array. You can use recursion as well for this particular thing, but in this video we will be looking at the easiest way uh, to find the subset of a given array. Now before finding that, let's say we have 3 bits and how many different numbers or how many different representation of these 3 bits are possible. Each of this bit can have two distinct values, right? So each of this bit can take either 0 or 1, right? So in total there are 8 distinct possibilities or 8 distinct ways in which these 3 bits can be represented, right? So what are those 8 ways? 8 ways are 0 0 0 0 1 0 0 1 0 1 0 and so on. So these are the 8 ways. Now if you convert this 8 8 binary numbers into their decimal format, you will get everything from 0 to 7. Now how to convert from decimal binary to decimal? Again, a simple thing. You will just this bit will the first bit or the last bit would contain 2 to the power 0, first bit would contain 2 to the power 1, and second bit will contain 2 to the power 2. So you can simply, if this bit is set, let's say we have to find the decimal value of this. So this has a contribution of 2 to the power 2. This has a contribution of 2 to the power 0. So 2 to the power 2 plus 2 to the power 0, which turns out to be 2 to the power 5. Sorry, 5 in decimal. So what exactly are we getting? So with the 3 bits, we are getting 8 numbers, and the numbers are from 0 to 7, right? Similarly, with n bits, we will be getting 2 to the power n numbers, and the numbers would be in the range 0 to 2 to the power n minus 1, right? So this is what we will be getting. Now let's, like with this in mind, let's talk about the original problem, finding the subset of a given array. So let's say this is the array 215, and we have to find the subset or all the subsets of this given array. Now what exactly subset definition is? So subset definition is a subset is an array that can be obtained by deleting some elements from the num, right? So basically each of these elements can either be present or can't be present in the subset. It is up to us to decide, right? So each of these elements has two choices. Either they will be present or they will not be present in the subset, right? So we can represent these two choices with a bit. So if it is present, I will say that okay, bit value is 1. If it is not present, I will say the bit value is 0, right? Now, with this, you can simply say that each of these represents a bit, right? Which have again two choices, 0 or 1. And we have to find out how many different combinations of these bits are possible. So this is exactly the problem that we just discussed a bit ago, where we have 3 bits and we have to figure out how many distinct um, combinations of these 3 bits are possible. So we already have figured out that given if there are n bits, it will contain 2 to the power n different combination, and in the decimal format the value of those 2 to the power n combination would be in the range 0 to 2 to the power n minus 1, right? So in this case as well, each of these bits will like the combinations will, there are total 8 combinations of these bits, and the combinations will be in the range 0 to 7, right? Now what, like the subset is not this combinations, right? What exactly the subset would be the representation of this combination. For example, let's say we talk about this combination. So this says 0 1 1. So what does it mean? It means that this is 0, this is 1, and this is 1. Now what does 0 means? 0 means that this element is not present in the subset, right? So what does 1 mean? When 1 means that this element is present in the subset, and 5 means this element is present in the subset. So this 1 means the 5 is present in the subset. So basically, this in turn denotes that the subset would be containing 1 and 5, right? So that's what the subset is. So each of these values will translate to some subset, which, and finally, like all these 8 combination will give us all the possible subset of the given array, right? So let's look at the complete list. So if you see, this is how the list would look like. So we have 8 combination, and each combination would give us some subset. So now let's say we have to do it programmatically, right? Now you have to write code for finding out this column. Now, what exactly will you do? You can simply say that, okay, I will do the same path. I will try to figure out all possible combinations of 3 bits. So I will figure out 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on. And then from that, I will convert this to the corresponding representation in the subset. So that is good. But that again, like figuring out this column is hard, right? We can't actually iterate over this column in code very easily. We have to write some kind of recursion again here, right? We don't want that. Let's say which of these three, like which of these two columns, like there are two columns, right? One is this and second one is this. Both represent the subset. Now, which of these two columns are easy to iterate? Second one, right? With basically we can just do a for loop from 0 to 7, and that's it. So let's say we don't have this column at all, right? We are iterating over this column, second column, and we want to find the exact subset. So basically we have to convert 0 to this, we have to convert 1 to 5, right? And we have to convert 2 to 1, and so on and so forth, right? Now how will you do that? You can say that, okay, that is also fine. I will iterate over this column and then convert this to the corresponding binary representation. And based on the binary representation, I will figure out what the exact value of the subsets are, right? So that is okay, but we can do something better here. Uh, Instead of directly going to binary and then asking, okay, if this bit is set, I will take this element. If this bit is set, I will take this element, and so on and so forth. We will simply ask what exactly, like whether two contains in this 0 or not, or whether the first bit is set in 0 or not, or whether the second bit is set in 0 or not, and so on and so forth. So if the answer of this question, that whether ith bit is set in 0 or not, or in this particular number or not, if the answer is yes, I will include that element. Otherwise, I will not include that element. right? So now what we need to answer is, for a given number, let's say 6, we need to answer whether 6 has first bit set or not, or whether 6 had second bit set or not, or whether 6 had third bit set or not, right? Now, this we can simply do this with a binary operation. So let's say this is the number, right? So this represent some number, and we want to figure out whether second bit is set or not. So what we will do, we will simply mark everything as 0, right? And do a bitwise AND. Now, bitwise AND would actually be 1 only when both the bit is 1, right? So in this particular example, we have only set the desired bit which we want to check whether that is set or not to 1. All other bits are 0. So basically for all other things, the value would be 0. Only this bit can be 1 or 0, and it depends on what exactly is the value at the original number. If the original number at that bit is set, then the value here would be 1, otherwise it would be 0, right? So we can say that if we want to check whether a bit is set or not, we can simply set that particular bit and unset everything and just do a bitwise AND. If the result of bitwise AND is greater than 0, it means this bit is set. If the result of AND is equals to 0, it means this bit is unset, right? So hope this point makes sense. Now we will do exactly same thing. We will say, okay, we want to, let's say 6. So we want to say whether first bit is set or not. So what we'll do, we will say, okay, 6 and 2 to the power 0. If the value of this comes out to be greater than 0, we will say that this bit is set. So you will, if you find out this, you will see that value is equals to 0. 6 and 2 to the power 0 is equals to 0. So that's mean that 5 is not present in this subset. Now we will do this. We'll do the same for this one. We will say, okay, 6 and 2 to the power 1 is the value greater than 0. So you will see the value here would be 2, which is greater than 0, and hence 1 is present in the subset. And same we will do for 6 and 2 to the power 2 and figure out that 2 is also in the subset, right? So what is the simple algorithm to find out all the subset? We will just iterate over everything from 0 to 7, and for each of these numbers, we will iterate over all the bits and simply perform a binary operation. If the result of the binary operation is greater than 0, it means that number is present in the present in the subset, or it is not present in the subset, right? So the pseudocode for the same would look something like this. So what we are doing is, we are simply iterating over everything from 0 to the power n, right? And after that we will, like, this is all the subsets. Now we have to figure out exactly what all elements are included. So for that, what we have done, we have iterated over all the indexes, and for each of these indexes we need to figure out whether that index is present in this given subset or not. So what we will do, we will simply do a bitwise AND of that subset number with 2 to the power of current index. If the answer is 0, it means it is not included, so we'll continue. Otherwise, this index is included. Now, whatever we want to do, we'll just do with this particular index. So that's the simplest form where you can find out subset. What we are doing, iterating over everything from 0 to the power n, and then iterating over every index and just checking whether that index is present in that particular binary representation of the number or not. And based on that, we know which element are present and which are not present, right? Now notice 2 to the power n. Every time you will not want to calculate 2 to the power n, right? Because that is tedious. So there is a simple way to calculate 2 to the power n, that is 1 left shift n. So this is just another uh, binary operator, left shift, which we can use to find 2 to the power n easily. So instead of 2 to the power n, we will just say 1 left shift n. What does it mean? It means that you will shift the binary representation of 1 and n bits. So if let's say the value of n is 3, it means we have shifted n 3 times. It means after after 1 there are 3 zeros, right? And this is the final number. So that's what we want, like 2 to the power 3, right? So that's exactly what we are doing here. And similarly, 2 to the power index can be transformed to one left shift index, right? So this is the simplest code in which you can find out all the subset of a given array, right? Now, if you are not clear up till this point, I would strongly encourage you to rewind the video and watch it yourself. There are various different problems that you can solve uh, yourself to make this concept a bit strong. I would like you can try out finding out all the subset sum or something of that sort. I will try to link some of the practice problem for this finding out subset, where you can apply this finding out subset algorithm and solve that problem. So I would try to link some of the problems there in the description below. So for now, what we know, given an array, how to find out subset easily. We will just iterate over 0 to, n, to the power n and figure out what is the subset. Now let's get back to the original problem. So original problem was that we need to figure out number of non-empty beautiful subset. Now, um, what is the definition of beautiful subset? Beautiful subset means that two integers, the absolute difference between two integers should not be equals to k, right? So first of all, we need to find out subset, right? So order of element doesn't matter. So as I always say, if order of element doesn't matter, always try to sort the array first, because that would help you help you think in a more structured fashion, right? So in this problem as well, the order of element doesn't matter, so we'll just sort the array, right? Now we need to let's say we consider one subset. So let's say we have taken a subset which contain these four elements, right? Now how can you determine whether this is a beautiful subset or not? One way is to just try out every possible pair and see if there is a pair which has an absolute difference of k. If that's the case, we will simply reject that subset. Otherwise, we will take the subset, right? So again, what is the time complexity of that solution? Time complexity would be for each subset you are iterating over uh, all the combination, or like all the pairs. So there are total to the power n subsets, right? And for each subset you are uh, iterating over every pair. So total n square pairs can be there in worst case. So this is the time complexity. Now this will surely not pass in the current problem. So we have to reduce this constraint. Sorry, we have to optimize this. Now how exactly will you optimize this? So again, encourage you to pause the video and try to think yourself first before watching the video further. So we need to somehow not check all the pairs, but still be able to answer that whether a particular number has is subtracted by something will give us k or not, right? So how exactly will you do that? Let's say for 4, you need to figure out whether 4 is paired up with some number and give us a difference of k. Let's say k is 2 in this example, right? So we need to figure out whether the difference between 4 and any number is 2 or not, right? So how we can approach this is, we can simply say, okay, when adding a new number, so one number doesn't have like this doesn't any subset which contain only one number doesn't is a beautiful subset. It can't be non-beautiful subset because it doesn't have any pair at all. Now when we are adding number, we can simply check whether that number minus k is present is already present in the array or not. So in this example we can simply say, okay, whether 3 minus 2 is present in this array or not. So if not, then I can add 3 without any issue, right? Similarly, when we are adding 4, we will check, okay, whether 4 minus 2 is present in the array or not. So 4 minus 2, 2 is already present in the array. So that's where we are saying that this subset or this subset is not a beautiful subset, right? So hope you get the approach. So what we are doing, we are iterating over the subset, and as we are keep on adding numbers, we are checking whether we encounter something minus k, whether that number minus k already or not. If we have already taken that number in our current subset, then current subset would not be a beautiful subset, right? So the pseudocode for the same would look something like this. uh, this is the subset code which we just looked at a while ago. So we'll iterate all the subset, right? Now this will be starting from 1. Now why 1 not 0? Because it says that we have to consider non-empty, and empty subset is the one with have value 0, because 0 means nothing is set. So if nothing is set means that is an empty subset, so we'll just simply ignore 0 and iterate over 1 to 2 to the power n, and that will give you all the subset in the range, all the subset which are non-empty. So for each of the subset, we will maintain a taken array, because we need to understand whether we have taken some number or not already, right? So we maintain the taken array, and now we are say like we are this is the usual subset operation, right? We are checking whether that number is present in the subset or not. If it is not present, we will continue. If it is present, we will mark that in the taken array, right? And then we will also check whether that number minus k is present in the array or not. If it is present, we will mark that subset as bad and break out from the loop. And if it is not bad, we will increment the result, right? So this is the algorithm which would solve the problem. Now, what is the time complexity of this algorithm? We are iterating over all the subset. So this is 2 to the power n, right? This loop will run 2 to the power n. Now, under this, we are iterating over indexes for each subset. So this will run n times, right? And inside this, we are doing some constant operation. Sorry, some constant operation, so that is fine. Now, notice that we are also initializing one more array here, and this array would be in the order of range. So basically, we will also take time to initialize this array, and number of elements is range. Basically, what is the maximum value of nums? So that is the value of r. So this is the final time complexity. Now this is definitely better than 2 to the power n into n square, but even this would not pass because r is up to 1000. So this is like 1000 into 10, 2 into 2 to the power n. This will not pass. But you can simply replace this vector with an unordered map, or uh, maybe you can take this vector out of the loop, because you know that only 20 elements can be modified. Even though it has 1000 elements, there are only 20 elements in the array, right? So only 20 elements can be modified here. So we don't need to initialize all 1000. We can simply initialize 20 elements, and then also mark them as not taken at the end. So what we will do, we will simply take out this vector out of this loop, right? And after we have done with this particular subset, we will unmark all the indexes. So we know that n is up to 20. So this loop will run up to n times. So now what is the complexity? The complexity is now 2 to the power n into n. But now this is 2n, because we are iterating over n twice. First, one for all the indexes, and then second for uh, uninitializing or initializing all the index, like all the taken value. So right, so this will be like this is not is taken, it is taken of nums of index. So this is the exact uh, thing which we will be uninitializing. So now even this would not pass in the current, like in the current constraint. Now what you will do, so again I would encourage you to pause the video and try to think it yourself. So this will not pass because there is an extra n here. If we remove this extra n, it will pass. So we need to remove this extra n. Now, which n will you remove? This one or this one? Now, pause the video and try to think yourself. So, basically, the idea is if we remove this n, right? First of all, we can't remove this particular n because we need to know which all elements are there in the subset. So this is something which is mandatory. We need to iterate over all of them. Now, second is we are iterating over all the indexes to uninitialize the taken array, right? So we can remove this particular thing somehow. Now, if we remove this, we don't have any way to do this particular thing as well because this would be already initialized to true. Like in the previous iteration, let's say if it is already initialized to true in previous iteration, and if we not mark it as false, we will not be getting correct results from here, right? So that's where there are two approaches now. One, we can say that okay, instead of instead of marking a particular element, what we are checking here, we're checking that whether nums index minus k, the index of nums index minus k is taken or not, right? That's where we're checking. So what we can do, we can simply find out the index of this particular element nums I minus k, right? And we can check whether this index is set in this subset or not. If it is already set, it means that element is taken and the subset is bad, right? So that's what we have done. Like if you remember, that's the exact same thing we have been doing already for one of the index. We have to check whether that index is present in the subset or not. So we can do the exact same thing for this other index as well. We'll check whether that index is present in the subset or not. So if the value is greater than 0, it means that index is present and we'll mark that as bad and break out from the loop. So this is one solution. Other solution is you can like notice that here the issue is we are marking it as true and just checking whether it is true or not, right? What if we mark it, if we make this boolean array to an integer array, right? We and for each of this iteration we have a different integer. So what we will do in each of this iteration, we will try to mark taken as the current subset value. Now, while checking as well, we will not check whether it is true or not. We will check whether it is equals to subset or not. If it is subset, it means it is already taken in the current subset, right? Otherwise, the value here would not be subset, it would be something else, right? So, by doing this simple trick, we can skip the uninitialization part completely, right? And this by this we like the algorithm would now become 2 to the power n into single n instead of 2n, right? And this would definitely pass. So this is one possible way to optimize it, and this is another possible way to optimize it. Now, in this approach, there is one more catch. If you are trying to code this with this approach, the catch here is you have to like this other index. There can be more than one index with this particular value, right? So this other index would not be a single index. Instead, it would be an array of indexes, right? So basically, let's say the array is 2, 1, 2, 4, and you are trying to insert 4, right? So what you want to check, you want to check whether there is 2 present in the array or not. So index of 2 is 0 and 3 as well. 0 and 2 as well. Like 2 is present at index 0 and index 2. So this other index is not a single value. It is an array of value 0 and 2. So you have to check everything for this array. Now instead of checking everything for this array one by one, what we can do, we can simply set both the bits. We can simply check whether 1010 is mapping, like whether any of these bits, one, the 0th bit or the second bit, is present in the subset or not. So what we can do, we can simply set both the bits and do a bitwise AND. So that would give us whether any of these bit is set or not. So if any of these bit is set, the value would be non-zero, right? Otherwise the value will be 0. So if any of this bit is set, we will mark that as bad and break out from the loop, right? So this is the edge case that we need to solve if we if we take this approach where we have considered the index of the element and checking it, right? So that's the entire solution. So again, I would strongly encourage you to pause the video right away and try to code this solution yourself with both the approach. I would strongly encourage you to code this particular approach as well, because this approach will come handy in other scenarios as well. So try it out yourself first and then come back to watch the video. So, okay, in this particular video, I would be mostly looking at discussing the code for this particular solution. The code for this would be exactly similar. It's just that we have to take an array and like use this particular logic instead of this logic for bad index, right? So the code we have, like we are first finding out the array which contains which all bit are set. So let's say the array is 2124. So for 2, we need to understand what all bits are there which have, like which all indexes are there which have 0. For 1, we have to understand which all indexes are there which have -1. So assuming that k is 2, right? So which all indexes are there which have 0, which all indexes are there which have -1. So these are the things we need to answer at this particular place, right? Now for this, we have to calculate this index array from before. So that's what we are doing. This is the index array that we are calculating. So what we are doing, we are iterating over all the indexes and then checking which indexes have absolute difference of k, and we are marking that index in the current index array, right? So basically, we are setting all the bits which contains the current index. Now after this, we just iterate over all the subset and then figure out, like iterate over all the indexes, figure out whether that index is there in the subset or not. If it is not there, we'll continue. If it is there, we'll check it whether there is any other index which is there which contain n minus, like which contains the current element minus k or not. So this can't take with I basically denotes all the indexes which have value num psi minus k. So if the subset is, if any of this bit is set in the subset, we'll mark the subset as bad, right? And finally, after this loop ends, we'll check whether the subset is bad or not. If it is not bad, we'll increment the result and return the result as an answer, right? So hope this entire solution makes sense. If you have any doubts in this problem, please post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you're not already. And I will see you in the next one. Thank you.